Hey, thanks for the patience and welcome to the talk about the symbiosis of Docker and Perl. My name is Miroslav Tynovsky, and I'm from Prague. I work for Avast, which is an antivirus company. You may know it or not. And I work on backend systems in that company. So we create software for the threat analysts, and I'm just another Perl hacker. This is my Twitter and my email address. If you have any comments or whatever later, you can contact me on that email address. In this talk, I'll be talking about Docker, about microservices, about our internal Mesos Marathon cloud, and about some supportive tools we use for creating Perl modules and creating applications out of them and deploying them to our internal cloud solution. This will be very practical talk, actually. I'll be showing much of our pipeline, how we work in my daily job, and so I hope you will get something out of it. But let's see. Yeah, I'll be showing I'll be showing a demo, so I hope it will be working at least as good as the presentation works, and then there will be questions and answers. This talk has two main messages that I want you to bring them out. One is that you can use Docker to package and distribute your Perl applications, and it might be a convenient way for someone else to run it. And the other is that if you are building a backend systems, you can use Mesos Marathon cloud to deploy them. So, about the Docker. How many of you are using Docker in production? Okay, not very many hands. How many of you have played with Docker? Yeah, this is much more. And how many of you never used Docker at all? Yeah, also some people there. So that's good. That's good. That might be at least somehow useful for you. I have some notes here, so I just bring it with me. Yeah. Good. So for those who haven't used Docker at all, many people describe Docker as a lightweight virtualization tool. I like more to see it as a thin layer around your applications, which enables you to bring your environment with that application and to ensure that everywhere you run it in the same environment. But the lightweight virtualization view is also useful if we talk about what image and what container is, because these are two terms that you need to know if you work with Docker. Image is defined by a sequence of file system changes which lead to creating the environment, and also it contains the parameters how to run your container. And the container is a running instance of the image. I'll show it in a while, so you will see what these words mean, more practical. And I'll also show what Dockerfile is. Dockerfile is just the definition file for the Docker image. So if you want to create your Docker image, you write your Dockerfile and run docker build command, and that's it, how you prepare the image. So let's see if I'm able to run anything. yeah, this is the very basic example I prepared for you. This is a hello world program in Perl, which just prints out hello world. And here's a Docker file to which out of this program it creates the Docker image containing that program. So let me run it and see what it does. I'll name it YAPC/hello. So that's the name of my, I forgot the build command. That's the name of my first Docker image ever. So you can see I've done it before, so it's using cache for building it. But anyway, at the end it builds a Docker image, and now I have two options how to run the program. I can run hello, which prints out hello world, or I can do docker run YAPC/hello, which takes some time but does the pretty same thing. So you can see that these two are the very same programs, but there's a huge difference between them, because the first one is a Perl program, the other one is a Docker image. So to run the first one, you need the Perl interpreter. To run the second one, you need the Docker command. And in such simple example, it's not a very big difference because you only need the Perl interpreter. But if my program had some dependencies, I could. The difference would be much bigger, because you would not only need the Perl interpreter but also the dependencies installed. Let's do another example to see what problems you can have when you start using Docker. And this is only slightly more difficult program. I think you can read it quite quickly. It uses Microservices framework to execute a web app, and it implements two HTTP methods. One is get for the root, and it just prints out a file, and the other is add, which just adds line to that file. So I think of this program as a presents list. So if I execute it, we can go through every one of you and add every one of you and create a list of attendees of this talk. Right, so this is the purpose of the program, and now I'll run it and start filling it, and then the talk ends, and this will be it. Okay. So let me first run it on my local host, and you see I don't have Microservices installed, so it doesn't work. Yeah, and I forgot to show you the Docker file for that. The Docker file first installs the Microservices framework, then copies the necessary files, and then runs it. So let me build that. This time I'll call it presents list. You see I didn't run this before, so now it really installs Microservices framework, and it's not running from cache, so it will take some time. But let's wait for that. And okay, so I probably should have run it before to avoid this waiting. Well, anyway, it will take some time, and then it's there. One distribution installed. Very good. So now we created this Docker image, and we can run it. Presents list. And if I run it, you can see that it actually runs. So this time it's better, because it takes together, or it keeps with the app also the necessary framework, the necessary dependency. So I can check if it actually does something, and it was localhost 3000. I'll increase that so that you see that it's unable to connect. Why? Does
The port of the Docker.
exactly. The answer is that the port 3000 is the port of the Docker container and not the port of my localhost machine. So what I need to do is I need to tell the Docker that I want to view the port 3000 as a port on my local machine. I do that with this parameter p, and you see that you see that the program is listening on the port 3000, but as I tunneled it to 8080, it should actually work at 8080, and now it does something, but the attendee list is empty, so it's showing nothing. But it's the second step. Let's see if we can add anyone to that list. Ooh, many curl commands, yeah. This looks good. So I'll add my colleague Lucia, who is here, to the list, and see if she appears. It says OK, so it probably, yeah, see, it says OK, so it probably did something. And you see she's really there. So she's my first attendee. Anyone else who wants to be added to the list? At least one, please. Can raise your hand and tell me your name. No one. I knew. Thank you. Ken Power. Sorry if I do the spelling wrong.
That's okay.
Ken Power. You have a lot of power. Good. It's in your name. You see you are here at the list of the attendees. Thank you very much. Good. So now we can terminate it and run again and see what happens. The list is empty again. I'm sorry, Ken Power. It's you just didn't remain on the list. Does anyone know? Does anyone can help me why this happened? Exactly. The file was only in the container, and when we stopped the container, we lost the attendees file, and we just restarted the presents list image, which contained the empty file. So now the file's empty again. I wanted to show that you can mount a directory from your computer to keep that file, but I will not be showing that. I'm just saying you can mount a directory from your local machine to the container and see the list of attendees kept, right? I'll skip this because we lost some time at the beginning, and I think you can follow that. Okay, so that's about Docker. Now, I hope everyone is on at least some page with the Docker image, also the people who haven't yet used it. If anyone has a question about Docker, it's a great time to ask now. No one, so, yeah, sorry.
How do you go about installing modules inside a Docker container? Aside from the
Once more, please. Here's the mic. Sorry. Never mind, I will repeat the question.
Testing? Yes, Jim. I was going to ask about how do you use other packaging utilities inside Docker, like say Carton or ProRoot inside Docker, or are you just using a list of modules?
I'm sorry, I'm not sure.
Is inside your Docker file, are you just using the individual module installations, or do you use, say, Kern for your own use?
if I use curl or sorry, curtain. Oh, I don't know what curtain is actually. So sorry. Carton. Ah, yeah, we use carton all the time. I'm sorry. I just didn't understand the question. I'm sorry. Yeah, for this was just a very simple example of to have an introduction, but in reality we actually use we have our internal DarkPAN and we push our modules into the DarkPAN and have the list of dependencies with the package, and then I install it by CPAN right from the Docker file. I'll be showing this in the demo at the end, so we will see how we do that. Thank you for the question. Is there any other question? No. Good. So now I'll be talking about what we use the Docker images for. I found and must have stolen this nice image from the internet because it shows very nice the difference between monolithic applications and applications based on microservices. Like monolithic applications are a big piece of shit, and the microservices are at least smaller. So so that's very good. What's the idea of microservices? I already said that. You want to build a single application, but instead of creating a big monolith, you create a set of services which together do one app. And each service should do one thing and do it well. That's the Unix principle. Each service is independently deployable, and this is something where the image is not precise. The microservices need to communicate, so not only they are smiling, they need to talk to each other. Yeah. Why is it worth doing? It's because microservices are small and are more easily testable. Why it's hard to do it? Because it's difficult to find a good set of microservices at the beginning and find good boundaries between the microservices and define the communication protocols. So sometimes people do monolith first and then split it into microservices when they have an idea about what the application should do. I'll be also talking about scaling. The microservice architecture is good because you can scale independently different components of your app. Here I have a use case for microservice architecture. This is something that we built at our company actually. And as I said, we implement antivirus. If a user comes across a file which no one else in the world seen before, and if this file complies a set of rules that it could be malware, we upload this file to our backends and do some deep analysis of that file so that we can inform the user if it was malware or not. And here's the architecture. We send the file and metadata. There's one service gatekeeper which just joins the two streams. Then it passes the work to task scheduler. The task scheduler runs different operations on that file, like there are those boxes, and it can repeat several procedures on the same file. And every box reports its results to the decision maker, and when the decision maker has enough information, it reports the result to the user. So this is something that we built on microservice architecture, and we actually didn't have a choice because it enabled us to use different resources, different platforms, and different languages for different components of the system. For example, some of those boxes need to run on Microsoft Windows, and some of those need to run on high-performant Linux server and are implemented in C. So this enabled us to compose the whole system out of out of the components. If we did it on one machine, or if we did it as a monolith, we would need a single application and single server with all the resources and all the platforms and all the languages needed for that, which is non-existing. So that's like it. Just one note about disadvantages of the system. One big disadvantage is that the services depend on each other. So if, for example, the task scheduler has an outage, it influences the rest of the system. So we try to fight this problem using RabbitMQ so that at least we keep the planned work for later when the system is on again. Okay, so that was about microservices. My next topic is Mesos. Apache Mesos is a system which abstracts your resources away out of your servers. So you put a set of servers there, and you only have a set of CPU, memory, or drive space there out of it. How does it work? It's composed of three components: Mesos masters, Mesos slaves, and Mesos frameworks. And here's how it works together. Mesos slaves report the resources of the agent machines to the Mesos master. And Mesos master aggregates all the resources and creates offers to the Mesos frameworks. For example, here one of those frameworks is this Hadoop scheduler. And when the framework decides to accept the offer, it just sends a task to the Mesos master, and the Mesos master knows which agent is able to execute such task, and then it executes it, and that's it. This image is overly complicated because here's several Mesos masters, but you can see that only one of them is active. The other two are just standby masters because only one of the masters is working at one time. There's more of them only because of redundancy, so that there's no single point of failure in the Mesos master. The second reason why this image is overly complicated is that there are two frameworks. In our infrastructure, we actually only use one framework, and this is Marathon framework. So I simplified the image like this. We only use the Mesos framework as an executor of our Docker containers. Here's something more about the Marathon framework. Marathon is something that you can use to deploy your Docker containers to the Mesos, and you do it as simple as passing a JSON file to an API endpoint. And you submit such API saying which container you want to run. It tries to run it on the Mesos framework. Yeah, I'll not be showing the web interface because we don't have much time. I will show it in the demo at the end of the presentation. So you saw Docker, you saw Mesos and Marathon, and that's the tools that we use for running our Perl and other applications. Are there any questions regarding Mesos and Marathon? Okay, so I guess you just read the list of supportive tools we use. We use Minilla for creating new modules. It's a Distilla alternative, opinionated, and we used it for everything. We use GitLab for storing our modules. We use Teamcity for testing, deploying or releasing our Perl modules to our internal DarkPAN Pinto. And we also use Teamcity for deploying to the Marathon framework. Yeah, we have a MetaCPAN GUI for our internal DarkPAN, and we use Docker registry for storing our pre-prepared Docker images. So that's about it. And now it's the time for the demo. When I saw how this presentation started with my missing connector to the monitors and missing internet connection and everything, I thought that I just got the bullet, you know. It's it's like that. It's Russian roulette. Okay, what I'll be showing in the demo, I'll show you that I've created a code and pushed it to our Git repository. So it will be a Perl module, and I'll show you. I'll create the two Teamcity builds, which one will build the Perl package out of that code and submits it to the internal CPAN, and the other will install that module from the CPAN, creates a Docker image out of it, and deploys it to the Mesos Marathon cloud. So let's see how it will work. I'll probably sit down for a while to run it, if the cables allow me to. All right, how much time do I have? It's 20 minutes or something. Good. First, where is it? It's not here. Good. I'm sorry, I first need to connect to the VPN so that I can access the internal tools. And I don't know how to do it because my network manager applet is not there. So what do? I don't know. I'll probably restart the computer and hope everything will work right away. Sorry, can any of the organizers help me to connect to my to my VPN? I don't know how to do it. Sorry about that. No. So here. So here's the bullet. I'll try to reboot the machine and see if it works or not. In the meantime, are there any questions regarding anything I've talked about so far? No questions?
Maybe just if you can tell us something more about your use case, how many containers, about the scale?
About the scale? Yeah. A colleague of mine probably knows more about it, but anyway, we have five servers running Mesos agents and 3 servers running Mesos masters, and we use this network to deploy. We have several more Windows servers, and we use this network to deploy a set of tens of microservices. So we started doing that a year ago. I'm sorry. And no. Everyone's password for network. I think my Ethernet connection doesn't work.
No, it doesn't. The
It
VPN shouldn't work on the wired connection.
Okay, so I'll disconnect the Ethernet. So, and I connect it to the
Wi-Fi.
good. Now I'll connect to the VPN. Thank you very much for coming. 4979. Looks good. Thank you very much. Yeah, we started building this microservice stuff like a year and a half ago. So it's not that high scale thing yet, but it worked very well for us. So I hope we'll continue and have even bigger infrastructure and more services running that way. So first, I pre-created Perl distribution out of the simple application I showed to about the presence list. So I only generated the distribution files using the Minilla tool and only copied one script that you already saw. That's the script that I showed for storing the people in the presence list. And I also added the dependency on module issues to the CPAN file. So, you can't see anything. I didn't know. Sorry. Okay, so good. Thanks for saying. Sure. All right, now it works in extend mode. I think I have 5 minutes to go. I'm not sure I'll be able to show anything actually, but let's see. I'll share the opposite side, and so that I can see. You'll see my back. I'm sorry, but yeah. 15 minutes. Okay, very good, very good. So let's see what we can do with that. I hope I don't break the connection. Good. Good. So, here, what we can see here? Can you see anything? No. Yeah. I need to. Now at least you can see something. How many of you are familiar with Teamcity? Not very many. So let me introduce you to Teamcity. It's a continuous integration tool similar to Jenkins. Is there anyone familiar with Jenkins? Yeah, many of you. So you can view it as the very same thing. It's a tool for defining a set of jobs that lead to deployment of an application. And this is exactly what I'll use it here for. I have 2 Teamcity projects, and you can view them as those jobs. And each of those jobs will have 2 steps. The first job is for building the code into the Perl distribution and submitting it to the Pinto, to the internal DarkPAN. And the other project is for building a Docker image out of this Perl module and submitting it to Marathon and executing it on the Mesos cluster. So here's the first job or first project. I'm sorry. Here's the, sorry. This is the first job. And now I'll create the build steps for the first build step will run the Minilla dist command, which creates a Perl distribution out of the code. And it will be a Docker. It will be a step of type Docker. So this step will execute a Docker container and run a command in this container. And here I put the name of the image on which the container will be based. And here I put the command that will be executed. So I am executing this command in Avast Software Perl Extended Docker image, which is our Docker image containing Perl and some set of modules, including Minilla, so that this command will do something in that container. Okay. Sorry, I missed the right field. This is for Docker parameters. I put it to the command. So this step will create the package. And here's another step which will submit the package to the CPAN. It will be a simple curl. So I'll run a curl which will do a post command. Dist. Honzo, můžeš mi to psát? Napiš nám ten form. Oh. So this command will submit the created package to our internal Pinto repository. And let me thank my colleague that he types it for me, because I'm not able to speak and talk at the same time, to type and talk at the same time. And this is just a simple HTTP layer over the Pinto. So this just executes a command. Are you guys familiar with Pinto? No one? Yes. Sorry, so please raise your hand. Right. Okay, so some of you. So it's a DarkPAN software. It enables you to create your internal CPAN for storing your Perl packages. Yeah. So we just created a simple layer, HTTP layer over the Pinto. So this web interface just calls the Pinto command to actually add a package to the repository, right? So we have the first two steps. I'm sorry about the blinking, but we have the first two steps. First, creates the package. The other submits the package. Nothing very difficult with that. What I didn't say is that this Teamcity job is connected to the Git repository so that it fetches first the code that I showed in the GitLab and then runs the commands on top of that. Yeah, can you please run that? Klikni na tu, frontu, podívej se na tu frontu a posuň to nahoru, jestli bude potřeba. Success. Good, so now it fetches the code from the Git. It already fetched. Now it pulls the Docker image, Avast software /Perl extended. Then it will run the minill list command, and then it will submit the package. Can you please do the other two steps? So now let's work on the other job, which will fetch the package from the Pinto repository, installs it into a newly created Docker container, stores it as a Docker image, and then submits a JSON saying marathon that it should execute that Docker image. Are you guys following me? Not really, okay. So this is the first step of the second job, and it runs docker build command. Yeah, I didn't show the. Jan, please show the second repository with the Docker file and the marathon JSON. So I have another repository. This is not containing the code of the CPAN module, but this contains the definition of how the Docker image should be built, and then it contains the JSON file describing how this Docker image should be run in Marathon. So this is the Marathon JSON file. It just says run a Docker container and this Pinto srv int avast.com. I'm sorry about the name. It's not Pinto anymore, but it's our Docker registry. It just incidentally runs on the same server, so it's confusing. But this you can view it as Docker registry /presents list. So this says that the image presents list should be run in the Marathon framework. Can you show the Docker file, please? And here's the Docker file that just installs the app presents list from our internal Pinto. This is our internal repository. And because it's dependent on Modulicious, I also include a standard CPAN mirror so that it has a source where it can install Modulicious from. OK, so if we can create the Teamcity jobs. So here we built the Docker image, and in the other step, we'll run this Docker image in Marathon. I'll give some time to my colleague to type that in. Are there any questions? Or yeah, thanks. Configuration for the service.
Bundle that with the Docker image, or how do you keep the configuration?
Yeah. So the question is, how do we configure the service that we run on the Marathon framework? Our practice is to build into the Docker file. So we create the Docker image containing the configuration. My colleagues from the company they use another approach, and they configure the service via environment variables, which they put to the Marathon JSON file. So these are the two options, or you can use combination of them. So you can put some configuration and enable the override with the environment variables. We are discussing quite a lot what's the proper way of doing this, but yeah, at the moment we are just putting it right into the Docker image so that it contains exact definition of the whole service, including configuration. Any other questions? No. That's probably it. I'm sorry for all the technical problems. But if you want to see that running, just find me out in the venue.